In Pidgin, all of the operators are reserved words, but in JavaScript, as in most languages, most of the operators are symbols. So the division operator, for instance, is a /, and the multiplication operator is an asterisk. An even bigger difference is that, like most languages but unlike Pidgin, JavaScript uses infix notation. So here we see x times 3 plus 9, and both the multiplication operator and the addition operator are binary operators. They take two operands, one on the left and one on the right. The question here then is which of these operations is performed first? Well, in prefix notation, our operators have an assigned order of precedence, and the multiplication operator has a higher precedence, so it's done first. So if we were to explicitly write the parentheses here, we'd first put a set around x times 3, and then we'd put another pair around the addition operation. So if we were to write this in prefix notation, it would look like this. When you call a function in JavaScript, it looks like this. First you have an expression which evaluates into the function being called. Usually that expression is just a variable. And then afterwards, in parentheses, you have a list of arguments, and those arguments are separated by commas. So here this is a call to the function foo with the arguments a, b, and c, and then we have a call here to bar with no arguments. Written in prefix notation, these two calls would look like this. Now be very clear that whereas in prefix notation a set of parentheses always denoted the invocation of an operator or a call to a function, in infix notation they do not. In infix notation we often have operations which are not surrounded in parentheses, and then we also have expressions which have superfluous parentheses around them. Here, for example, we have an expression of the variable foo, which simply evaluates into the value of foo at that time. In infix notation, if we surround it in parentheses, the parentheses don't do anything, they're just superfluous. In fact, we can put as many pairs of superfluous parentheses around foo as we like. In prefix notation, though, we can't do this. We have to just leave it as foo with no parentheses. Because if we included parentheses, it would then be a function call. And if we are invoking a function in infix notation, the parentheses always come afterwards. Any parentheses we put around the call are just superfluous. Assignment in JavaScript is considered an operation, not a distinct kind of statement. The assignment operator is an equal sign, and you put the target of its assignment on the left, and you put the value being assigned on the right. So here, for example, the division operator has a higher precedence than the assignment operator, so the division is done first. So bar divided by 2, that value is assigned to the variable foo. If we were to write this same expression in prefix notation, it would look like so. Now you may be scratching your head a bit because it is a bit odd at first to think of assignment as an operation. First of all, the target of the assignment, the thing which is the left operand, is not really an expression. Normally operations, the operands themselves are expressions, but not in this case. In an assignment operation, the left operand is not an expression, it's a variable name. Or to be more accurate, the left operand must be what the specification calls an L value. L simply standing for left. An L value is something which can go on the left side of an assignment operator, in contrast to an R value, which is anything that's allowed on the right side of an assignment operator, which is any kind of expression. A simple variable name is the most common kind of L value, but as we'll see later, there are actually a couple other kinds. The other oddity of assignment as an operation is that it then raises the question, well, what does that operation return? The answer is that an assignment operation simply returns the value that is being assigned. So this assignment operation here returns the value assigned to foo. So because the assignment operator returns a value, we can then do something like this. Here we do the addition operation first because it has the highest precedence, and then we do the rightmost assignment operation first because the assignment operator is right to left associative, meaning that if we have a chain of them, we start on the right and work leftwards. So 4 plus 2, that produces 6. We assign 6 to z, and then we assign 6 to y, and then we assign 6 to x. If the assignment operator were instead left to right associative, this wouldn't work because what you would have then is first the leftmost assignment of x equals y, and then you would have assignment of the value of z being assigned to the expression x equals y. But the expression x equals y, that's not a valid kind of thing you can assign to. It's not a target. It's not an L value, so it's not legal code.